Hey, Alan, welcome back. Hi, Faith.
Hey, Mr.
Welcome.
Brown.
What's going on, Alan? All right?
I'm doing good.
Hi.
Hey, how you doing? Welcome back. Hello, Kai. Welcome back. Hey, Santino. Welcome back. Good morning, Ryan. Welcome back. Hey, Zen. Welcome back. You're doing well. Hello, John. Welcome back. Hey, Nadal. Welcome back. Hello, Asim. Welcome. Hello, Irvin. Hello, Kim. Welcome back. Joey G. Welcome back. 8 to 10. Welcome back. Hello, Joseph. Welcome. Hey, Thelman. Happy Friday. Hopefully you're doing well. Hello, Jumila. Hi, Nadina. Welcome back. Hello, Michael. Welcome. Hey, Alex. Welcome. Welcome to best class today. Wendy, Sam. Good morning. Hello, Tristan. Welcome back. Okay, I'm gonna wait till 11:42. Please set up your screen the way you want it to look. Get associated, get your Google Docs up. Hi, Makai, welcome.
Hi.
Hello, Emma, welcome back. Hey, Phil, welcome. Hi, Frank, welcome back. Jordan. Jordan's here. Sorry, Jordan. Welcome. Missed you. Just Leonardo then. Okay, please check the attendance to the left. Please make sure it's accurate, precise. Please make sure that Leonardo, I don't think you're here, so if you're here, unmute yourself or throw it in the chat. All right, welcome back. I hope you guys are all doing well, staying safe and staying warm as well. Friday, day before Halloween, and see what happens tomorrow. Just a little heads up, if you do go out or if you have trick-or-treaters coming to your house, be smart about it because COVID cases are almost at 30 again the last couple of days. So it's starting to increase again. I think I read a report this morning saying yesterday's COVID numbers were the highest in the nation they've ever been. Don't know if it's valid or not. Read it this morning, my Google feed as I go through it. And I wake up in the morning, go through that stuff, my little newspaper. So be smart, be safe. Don't want anything to happen to you guys. Don't want you guys to get sick for this stupid virus. It's stupid because it killed a lot of people. I don't like it. And obviously doing a lot of harm to society. All right, welcome back. So here we go. Happy Friday. Quote of the week. Science is simply the word we use to describe the method of organizing our curiosity. How is this virus so dangerous? Why? Still got to ask that question. What's going on with this virus? Curiosity. Don't stop being curious of asking why, how. Going to college in a couple of years? You're going to be curious. How do I do this application? Do I qualify for financial aid? Get a car. How does it work? Why do I need to replace brake pads every few years? Why do I need new tires every few years? How does my engine work? Buy a house? How does it work? How does my heater work? What's it made of? All that stuff. Don't stop asking why. Today's agenda, daily agenda for Friday, October 30th, 2020, day 2. It is continuing on unit number 3 of the atom. We're continuing with subatomic particles. A lot of stuff today. We're going through notes, a YouTube flick, analyze several review questions. There'll be several examples we go through in class, and I will analyze some questions in the exit pass if we have enough time. Things that are due for this week, you have topic number 1, exit pass, topic number 2, exit pass, and that lab we did on Monday is due tomorrow. So the lab we did on Monday, beginning of the week, is due tomorrow as well. This right here we'll do in class. All right, so picking up where we left off, you definitely need your guided notes. Hopefully we all know how to access our guided notes now. Classwork, Unit 3, the atom guided notes. You may want the key to assist you as well, but you definitely want a reference table. So that hard copy of the reference table I sent home, have it nearby, because this is going to be a pain in the you-know-what to go back and forth through and use this all the time. You're more than welcome just to watch my screen and split the screen like that and obviously mimic here, but when I zoom in on like an element really quick, I'll zoom in on something quick, and it's going to be tough for you to find it. It is for me. So you'd be like, oh, where the heck did that come from? Or what page is that? So we're really going to focus on page 9, the periodic table for today. But I need that as well. The guide notes, I'm probably not going to use too much today. The key for the guide notes, I'm probably not going to use much today. Nope, I'm not going to use much at all today. So I'm just probably going to have a big screen of my guided notes that I'm copying down and the periodic table. All right. Let's check it out. Before we jump into that, let's go through some stuff here. Jordan, the hot seat today. Let's go through how are we doing, okay?
I'm doing good.
Good. Welcome to the best class of the day. You ready for this, Jordan?
Sure.
You got the hot seat today. What is kinetic energy?
Wait. It's the energy that's released.
Energy that.
Wait, no. Yeah. I'm trying to think back on to like 8th grade because I remember potential and kinetic. I'm pretty sure kinetic is the one that where like it's all released.
Yeah, energy in motion. So yeah, kind of energy release or energy in motion. Which phase has the greatest kinetic energy? Solid, liquid, or gas?
I think it's gas.
Gases do. So as I asked Jordan these questions, hopefully you could answer the questions yourself as well. Okay. What's sublimation?
It goes from gas to solid.
Sublimation starts with an S. It goes from solid.
Oh, solid to gas.
What's deposition?
Is that gas to solid?
Gas to solid. What is heat of fusion?
Oh, I forgot this one. I remember this. Heat of fusion. Can I look at my notes or no?
Well, we can just talk about it. It's not really a huge deal. So that's a heating curve. Heat of fusion is going to be at this point the heating curve. Heat of fusion goes from the solid to the liquid. Heat of vaporization would be here. That would be the next question I would have asked. Heat of vaporization is there. So these questions I'm going to ask for maybe once a week or so to someone new, hopefully, And these are the concepts that you should definitely pull out, the main concepts from the other thing. Next question, what is a ideal gas? Last unit
Um,
still.
hmm,
Anybody know that? You put it in the chat. Ideal gas? Ideal gas. High something, low something. High temp, low pressure. Thank you. Ideal gas is high temp, low pressure. Ideal gas, high temp, low pressure. Next up, how do gases move in a container?
they're all spread out.
They're spread out. Circular motion or straight line motion?
What'd you say?
Circular motion or straight line?
Straight line.
Yeah, they're definitely straight line. So I'm trying to get to the kinetic molecular theory. They move in a straight line. They transfer the energy. They take the shape of the container. All that stuff for kinetic molecular theory. Let's jump into the atom now. What was Thomson's experiment for the atom?
You did like the cathode ray tube, right?
Cathode ray tube. What did he solve, or what did he discover about the atom from that experiment?
Subatomic particle.
Called proton, neutron, electron.
Electron.
He discovered the electron. So Thomson discovered the electron. Next up, Ernest Rutherford. What was his experiment?
But the gold foil thing.
The gold foil experiment. And what did he prove?
Um,
What did he
well, I
solve?
forgot. Hold on. The atom is mostly empty space.
Yep. And he also had something else. The solid thing in the middle was,
Oh, the center of the atom is dense, positive core called the nucleus.
yeah, so the center is a nucleus, is a solid, dense core for his atom. So we should know what Rutherford concluded. What do you know about Bohr? Anything about Bohr? Niels Bohr?
He had like something to do with a planetary model.
Good. And electrons orbit around the nucleus. So there's a nucleus. Oh, there it is right here, actually. There's Bohr. There's his nucleus. And then electrons orbit around it in orbits. Oh, there's Thomson up there too. On my board. What's the wave mechanical model?
Energy moves in areas called orbitals.
Orbitals. It's a probability of finding electrons. So you should definitely know, everybody should know the process of the development of the atom. Proton number is the same as what?
The atomic number?
Atomic number. Which two subatomic particles are in the nucleus?
Wait,
What's in the nucleus?
wait. Electrons? No, wait.
Which two things are located in the nucleus?
I keep thinking of the things from biology.
Protons, neutrons, or electrons? Which two of those are in the nucleus?
Neutrons?
Neutrons and protons. Thank you, Justin. Protons and neutrons are in the nucleus. What's the mass of a proton? You could check out your notes if you want. It's totally fine. Mass of a proton.
One.
1 AMU. Mass of a neutron?
1 AMU.
And electron's so small, just orbits around it. So you told me protons. Yeah. So what you told me the protons and neutrons are in the nucleus. They have the mass. So that's why when Rutherford penetrated the gold foil, when something hit the nucleus, they bounced off because it's a solid, dense core. The electrons are so small, they orbit around it. When the particle or laser went through, most particles went right through. So they're not going to be affected by the electron cloud. But when particle hits the nucleus, they bounce on back or bounce in a different direction. Which two particles have the same mass?
Protons and neutrons.
Protons and neutrons have the same mass, 1 mu. What's the charge of a proton?
+1.
Neutron is,
0.
an electron is,
-1.
cool. Pretty good stuff so far. What is temperature? If you're defining temperature to someone on the street, what are you going to say it is?
Like the weather, or like how hot or cold something is.
Okay. Define temperature. Everybody know for that? Throw in a chat, please. Define temperature, please, in terms of chemistry. Maybe in terms of kinetic energy. Define temperature in terms of kinetic energy. Anybody? So I'm not picking on you. We're going through this together, and these are the things that you should know. You're like the first one I went through with this. How fast the particles are moving. It's the average kinetic energy of particles. So we talked about temperature. It's the average kinetic energy of particles for temp. So that one you should be aware of too. And we left off talking about subatomic particles. Thanks for playing, Jordan. Appreciate it. Okay, so someone else will have a different time to shine a little bit later throughout the year. Obviously, hopefully I'll try to get to everybody. Obviously, as we continue throughout the year, there's going to be more and more questions that you'll have to remember. When I do this like random review, this mass review I call it, then those are like the key concepts that they ask on the regents, and that's a review for the entire year. So I think about mentally, I think of unit 1, unit 2, unit 3, and I pull out like the important concepts that you should at least hold on to. All right, so here we go. Picking up where we left off last class. We left off with this chart. So nice job with that mass review. We left off with this chart, and then last class we left off with highlighting protons, electrons, atomic number, and the nuclear charge. So why do we highlight those the same color? Don't this little box in here. This is on Zoom annotate. So protons, electrons, and atomic number are all going to be the exact same thing. That's why they're highlighted the exact same color. I'm going to go a little crazier. I'm going to highlight these teal too, just so again you could see that they're the same numbers. So 17 protons, 17 electrons, the atomic number is 17, and the nuclear charge is 17. You don't have to do this. I'm not going to do this for every one. This number on the bottom we did last time. We analyzed that last time too. That is representing the proton number or the atomic number. So all the teals are the same number. They're going to be for now. Next up, we have the next value, which is the mass number. I'll analyze the pink now. The mass comes from the protons plus the neutrons added together. So that value comes from adding the protons plus the neutrons. The mass number is also going to be in the equation for standard notation upstairs. It's also going to be represented in this notation, symbolic notation, after the symbol. So that is the mass for all of these. And then the number of neutrons, that's a calculation you're going to have to memorize. I'll definitely ask this all the time. How do you calculate neutrons? Mass number minus the proton number. Yeah, last time I kind of ran through that quickly. That number on the bottom, we have to edit that to 17. I think it was 14 before maybe. That has to be 17. There was a typo before. So please make that change. That should be 17. No problem. All right, so let's analyze the next one. So you're going to have to make these connections. You're going to have, the more you do these, the more examples you see, the easier it's going to be. These connections have to be made. You have to know these values are all going to be the same. You have to know how to calculate neutrons. We're going to have a lesson on atomic mass and mass numbers. So we'll eventually get that. But the mass of an atom, just like Jordan said, the mass comes from the protons and neutrons. The electrons are so small, we don't even account for that mass at the end. So here we go. next situation, we only have 2 values given to us. We have 15 for protons and 16 for neutrons. That's all I have. So without even analyzing the periodic table, I know there's 15 protons. Therefore, my electrons must be equal to 15. I also know my atomic number is equal to 15. And I also know my nuclear charge is equal to 15. I guess I have one more I could analyze too. Let's put these two again quick. I'm just making them teal so you can see those connections. The number upstairs we don't have yet. We don't know the symbol. And we do have the atomic number, which is equal to 15. So that number we do have.
How did you get the 15s and like all those 15s you got in the second row?
This is a whole new element we're analyzing. So the only thing I think that was given to us were protons. In your sheet should only be protons and neutrons. After I had that information, I know that protons are also equal to electrons. It's also equal to the atomic number, and it's also equal to the nuclear charge. And I guess lastly, it's going to be the bottom of the standard notation. So since I had that 15 initially, I was able to plug that into the other parts of the equation. So basically, in our notes from yesterday's class, up here, this stuff right here told us protons equal the atomic number. The nuclear charge equals the proton number or the atomic number. The electrons equal protons. So I just highlighted all that stuff to make those connections. All right, so just from 15 and 16, we were able to put, just from this 15, we were able to put all of those 15s in those spots. The mass number comes from the protons plus the neutrons. So I'm taking my proton, I'm taking my neutron, there's my proton number, there's my neutron number, and I'm adding them together. 15 plus 16 gives me 36. So there's 36. I know the mass number, so now I can plug 36 into this equation, 36. One last thing I have to do is figure out what element I'm dealing with. So now you have to use a reference table, say, what the heck is this element? So you have your periodic table.
Wait, I'm confused.
Yep.
15 plus 16, right?
Oh, 31. I'm so sorry.
31. Okay, just a second.
Thank you. Thanks for catching me. I make mistakes. Can't add. Use a calculator. 31, not 36. Thanks for catching me on that one. All right, so now we have, let me change that one too. All right, now we have to figure out which element we're dealing with. So now you have to use a reference table. Now we have to figure out which element is element 15, or which one has an atomic number of 15. So again, if we zoom in on the periodic table for the key, and we know some basic information about chemistry now, the atomic number is what identifies an element. Just like your social security number identifies you, the atomic number identifies which element you have. So I'm looking at the atomic number, which is 15. Now I'm going to find element number 15 on the periodic table of elements. So let's look for element number 15. Element 15, this periodic table is organized by increasing atomic number. So it's like reading a book top to bottom. You have 1 and left to right. Then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's my 15. So that's the element we're going to be analyzing. That P, which is phosphorus. So P is element number 15. See it there. That's a proton number. That's a neutron number. I'm sorry, proton number. That's the electron number, nuclear charge. It's a lot of information there. There's my P. I'm going to put P for the symbol. And then the mass, which is 31. Phosphorus, 31. So now we know which symbol it is. Take change this here. Now it's going to be P. Notice that the mass that I have here is very similar to the mass on the reference table as well. It should be similar. It shouldn't be like 3 off. It should be within maybe 1 or 2 for that value. It could change because the neutrons could change. Questions on example number 2. All right, example number 3. The only information I have here is going to be C14, and I have neutron number. So C14, and I have number of neutrons. All right, so I'm going to plug some more information in. That 14, I guess I should put this up here. If you have the symbol, and then you have, if you have a symbol, I'm going to call it X, the next thing is going to be the mass number. So that little key, you have the symbol, the next thing is going to be the mass. So that right there, that's my mass. That 14 is my mass. Okay, yeah, you can do that way, Tristan, good. Yeah, so my mass number is going to be 14. Now we're going to have to find out protons, neutrons, electrons. I have C14. Let's check out the reference table again. Find your C. I'm still on that page for C. Let's go to the key. So carbon is actually the key for the periodic table. You have all this information. I'm going to focus on the left right here. All right, so carbon, we have protons, is the same thing as atomic number, which is going to be 6. We know 6 protons, it's going to have to be 6 electrons, because this is going to be electron configuration, which is going to be 2 electrons on one shell, the first shell, and then 4 on the second shell. So if you add them both together, that would give you 6. Protons also equal electrons for now. The atomic number is 6, and so is the nuclear charge is equal to 6. The standard notation, we could solve for that one. It's going to be the mass upstairs, which is going to be 14. Enter. The symbol is carbon. Enter. And then the proton number, or the atomic number, is going to be the last thing you list, which is going to be 6. There's,
Mr. Bond, I'm like really confused with this. Like, I don't get it.
it's going to take some time to really get this under. Did you highlight all this information like
Yeah,
I did?
I'm trying to keep up. I just like, and then I look and like you got like a 14. I'm like, I don't know where that came from. And then it's like the side number, the standard notation. I have no idea how you're doing that.
All right, let's try this one. You're going to help me out with the next one. You're going to help me out with oxygen. You got this. Just relax. We'll get it.
Okay.
All right, so we have only thing given to us is 8, and then you have 16, 8, and 0. What's the 16 stand for?
I'm trying to type it in.
The pink.
The mass number?
Yeah, so I didn't highlight them anymore because we'll eventually get this. 16 represents a mass number. So I'm taking that 16 and I'm putting it in for my mass number. And if you look at my key, there's another pink up here, which happens to be right there. Color that in there too. That 16 also represents this mass in the beginning. So the first thing I label, so I'm all the way at the left of this chart, is going to be the symbol, which is O. This is just another way that chemists represent just notations here. Oxygen. And then the mass you said is 16. Questions on that one?
No, I got like, yeah, that's like, how do you fill in the middle, like the little ones, like protons and
All right,
neutrons?
so this right here, that number, let me go back up my notes a little bit. We did this the other day in class. That number on the bottom is going to be the atomic number or the proton number. So that little key we're gonna use again, because the top number is a mass, the bottom number is going to be the proton number or the atomic number. So now we know what this 8 is going to be. 8 stands for what again?
The atomic number?
Atomic number.
Oh.
So it's the atomic number. So this is 8. If you know there's 8 for atomic number, you're going to fill the rest of these teals in with 8 too. If you know there's 8 for atomic number, you know that the proton number is equal to the same value, 8. We also know that the nuclear charge is also equal to 8. So again, what's up?
No, I said yeah.
Okay, all right. So you know where those 8s came from. They're all the same values. Teal, 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 teal. It's not so bad yet, I don't think. And then the neutrons is going to be calculated by the mass number subtracted by the proton number. Find your mass number. There's my mass, it's pink. It's 16. And subtract it by your proton number of 8. How many neutrons? Use a calculator if you need to, I don't care.
What would you calculate?
So the mass number minus the proton number. So the mass is 16. That's 16.
So
16
8.
minus 8 is 8. All right, the more you do, the better off you'll be. I guarantee it. Thanks
Okay.
for volunteering. Anybody else want to volunteer? But you guys do it with me, then me just do it. Well, Kai, your time to shine. We have this next one. You could either unmute yourself or throw it in the chat. I appreciate it. Either one of those. Whatever you decide. Okay, Kai. Ready? We have AR 40. What's this 40 represent?
Number?
What was that again? I didn't hear you.
Is it the atomic number?
Let's see. Atomic number of the situation. Let's just check it out. My key above. So right up on top here, it says X, then the mass. So that is going to represent the mass. So that first number is my mass. So that goes right here. So that's going to be 40. And then we know that's my mass. My mass is also going to be in the standard notation, which is going to go like the bottom, or I'm sorry, to the top over here. Like the pinks. I took all the pinks. Now the 40 is going to go up on top. I'm going to press enter. We know what symbol we have. It's AR. And then I'm going to press enter so we can figure out what the last number is going to be. We'll figure that one out. All right, so we're analyzing AR. We don't know what AR is. So now I'm going to check out the reference table. Split screen here. Let me zoom on out. And I want to figure out what AR is or where the symbol for AR is. So I'll make this bigger for a second. All right, so you could be here for a while looking for AR. The more you get familiar with it, the better you're going to be. But if you go to the next page of the reference table, maybe this is easier for you to analyze. You're looking for the symbol of AR. So you're scrolling down the symbols, looking for AR. Once you find it, you can obviously figure out what the name is. AR, there it is, element number 18. So this is the next page of the reference table. It is argon. Argon is AR. Oh, we also have something else there. It also tells us the atomic number for argon is going to be 18. So that 18 is the atomic number. Now I could look for number 18 for the atomic number here. Find number 18. Oh, there it is, 18. And you can figure out more information about that element as well. So it's like a little puzzle. We're figuring a lot about the puzzle for argon. Argon, there it is, AR. What's my atomic number for argon, Kai?
18.
18. So that number right there is 18. That's my atomic number. So once you know like how to analyze one of these elements, you know how to analyze them all. It's going to take a little practice before you get there, but you figure out all the information here, You're in good shape for the rest of them. What else is 18, Kai?
The electrons,
Electrons is 18. What else?
the nuclear charge.
Nuclear charge. That's a charge of the nucleus. Anything else?
Last number of the standard notation.
Last number. That's going to be the atomic number or the proton number. That's AR. And it's going to be 18 for the proton number. So proton would be 18 as well. So what I did yesterday at the end of class, I color-coded these so you can really make those connections. Maybe you have to read through this text above just to really make those connections as well. So this you're really going to have to know. Thank you, Kai. All right, let's check out one more example, then we'll actually draw one as well. Let's go through the last one. Hello, Emma. Please unmute yourself, or you could type it in the chat. That's fine as well. All right, so Emma, hopefully you come on board. Maybe you're going to type it up. The only information we have here is, zoom out one more time. The only information we have for the last example is going to be the mass number and the atomic number. How many protons do we have here? How many protons do we have in this one? Faith, you around?
Hi,
Hello, how are we doing?
pretty good. How about you?
I'm okay, thank you. Thanks for asking. No problem. So we'll have to review this. If you guys don't understand how to do some of these, then you just have to review it a little bit more, and we'll do more questions through the whole class. So anyways, here we go. So we have 20 for atomic number. How many protons do we have in this situation?
20.
20. How did you know that?
It's the same.
Atomic number equals proton number. That's how they know it. How many electrons do we have?
20.
How did you know that?
It's the same number of protons and electrons.
Thank you. Good. What's my nuclear charge here?
20.
How did you know that?
It's also the same.
Okay, so it's not too hard how she figured it out. She might have looked at this color code, or maybe she looked at the text above saying, okay, I have my atomic number, my electron number is the same, so is my proton number, so is my nuclear charge. All right, the mass number is given to you. How many neutrons do we have here?
20.
How did you get that?
The mass number minus the proton number.
So 40 minus 20 equals 20. Thank you. Standard notation, let's go through this one. What's the number upstairs?
40.
40, because mass goes up on top. We'll figure out the symbol in a second. What goes on the bottom?
The atomic number 20.
20. 40 over 20. And then we'll figure out the symbol in a second. Over here, we're going to have a symbol. What's the number after the symbol?
40.
40. The mass goes after the symbol. All right, now I want to figure out what the heck element is this? What element is this thing we've been talking about? So from the information, any idea which element we're analyzing here?
Hang on, let me get to my
No problem.
reference table. Number 20 is it calcium?
Ca. Why'd you use number 20?
Because that's the atomic number.
All right, so she checked out the atomic number. That is what's used to identify an element. You could have used proton number at 20 as well. So thank you very much. So she found 20, element number 20. She looked at the periodic table of elements. She found and located element number 20 by looking at the atomic number. And she looked through it, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 20 right there. Once she focused in on 20, she knew it was going to be Ca. There's Ca. And there's the atomic number of 20. Excuse me. So she realized that the mass is pretty darn close to what she put. There's my atomic number or the proton number, nuclear charge. The electrons could have been calculated by adding 2 plus 8 plus 8 plus 2, which would have gave her 20 as well. So thank you so much for that. Thanks for explaining it to myself and everybody else. Hopefully you know where those values came from as well as she did. So awesome job with that. So hopefully you could get, if you're not there now, hopefully you could get where she was with answering those questions. If you didn't know what the name of Ca was, you can look at the next page, look at element number 20 and say, oh, Ca is calcium. So yeah, you could have figured that out as well. Nice job with that. So I'm going to fill in my last things here on this chart and say, oh, Ca, so it should be a capital C followed by a lowercase a. And then Ca should go in the symbol over here too. All right, I'm ready for some questions on this now. So after those examples, 6 examples, you should have a pretty good understanding on it, but I'm ready for whatever questions you may have still. All right, let's go through something else. We'll draw an atom of this. So right below, I'm gonna press enter, I don't know, 10 times or so, just so I have some space, because we're gonna draw an atom here of what it actually looks like. So next up, does anybody need more time before I make a drawing here? And I say you do that too. We're good. All right, so what you're gonna do, you're gonna highlight from carbon. So take carbon, highlight carbon all the way up to the top. So you have the first 4 rows highlighted and all the text in there as well. So highlight that, please. Hit Control C, which is copy. Copy that. And then, this is huge here. After you copy it, click below the table. Make sure you have that little blinking light below the table. Once you're there, go to Insert, Drawing, New. Drawing, New. And now we're going to paste that box we just copied right into here. Control V. Right, there it is. Took a couple clicks for me. Okay, so I'm going to refresh, tell everybody what I did again for a second time, just in case you didn't get it. So if you have that, leave it alone. So what you're going to do, you're going to highlight from carbon all the way up to the top of the text box, the chart. Hit Control C to copy it. Click below the data table. Make sure you have that little blinking light there. Click below it. Once you have that blinking light, go to Insert, Drawing, New, and hit Control V. Takes a second to download for at least mine. Anybody not have this yet? Okay, we're just going to analyze.
Yeah.
One more time? Gotcha.
Yes.
Okay, starting fresh. So if you don't have it in here, this is for you. 3rd time the charm. Here we go. So whatever device you're using, highlight from carbon all the way up to the symbol. Make sure you have like the blue insert, the blue fill behind it. On your keyboard, hit Control C. That gives you the function to copy. Scroll down on the table. Get that blinking light there. Click. Just click on the below the table. There should be a blinking light. Go to Insert, Drawing, No. Click the drawing and then hit Control V. Paste it. You okay, Santino?
I got it.
Nice. Anybody else want to see it again? Fourth time the charm. All right. I think we're good. All right, next up, we're going to highlight the P column and the CL column, both those columns there. And just hit backspace. Once they're highlighted, those two columns, backspace. That's all I want, just like that. So highlight the two columns above and just hit backspace. If you need help, please ask. I can't see everybody's screen. There's 27 in here at a time. I can see your faces though.
Should we unhighlight them?
Once it looks like this, then you can unhighlight it. Does it look like this or no?
Like mine has like you see like how you had the blue, yellow and stuff. Yeah, it looks like that.
All right, so once it's highlighted, highlight them all again. Highlight them and hit backspace. So
No, I'm saying for like the C14 one. What if you had it highlighted? Would you unhighlight everything?
Okay.
No, like with like a blue or like a red, gray.
No, you're
Like
fine. You can leave the colors in there. That's fine. I'm not worried about that. All right, so now we're going to make an atom for this carbon. This carbon right here with 14, C14. So here we go. If we had a piece of paper, it'd be pretty easy to do, but we're going to work on the skill of making one. So the first thing up, I'm going to start off with a shape to make a nucleus. So shape, shapes, and then oval. Shape, shape, oval. Click that one. On your keyboard, hit Shift, and then drag it on down. It's going to give you a nice perfect circle. Nice symmetrical circle. What just happened? Shapes, oval, Shift, press your pad, your mouse, drag it on down, release. This is going to be my nucleus. Okay, what's in the nucleus again? I forgot. What particles are in the nucleus? You chat or unmute yourself, please. Thank you, Joseph.
Protons and neutrons.
Neutrons, good. So protons and neutrons. So I'm gonna click inside that circle. I'm gonna make my font like the 10. And I'm gonna put protons, which is gonna be just a symbol, P positive, and it's equal to a value. So it should be a lowercase p because the capital P represents phosphorus. So again, once I press spacebar after that, it gave me a capital P. To get rid of that, all I have to do is hit Control Z. So again, P plus, once I hit spacebar, it's a big key, it's a capitalized key, hit Control Z to undo it. Protons equal, and then we have it above, there's 6 protons. So I'm just gonna say protons equals 6. Joseph told me that in the nucleus are protons and neutrons. The symbol for a proton is P plus. The symbol for a neutron is N0. It should be a superscript, but I'm not too concerned about that. To get the superscript, it's control period if you care about it. Control period brings it back on down. So neutrons, if you don't like the, it shouldn't be a capital N, it should be lowercase, so hit Control Z. Neutrons equals 8. There's 6 protons, 8 neutrons. So in a nucleus, the solid dense core, we have protons and neutrons. The charge of a proton is positive, the charge of a neutron is neutral. Expand beyond this. I'm going back to the P, and I'm gonna press enter. And protons are positive, what? Positive 1. I'm putting 6 positive signs in here to expand our knowledge. 1, 2, 3, 4, 5, 6. Guess I'll stretch this out so it's a little bit bigger. We have 6 positives, and we have 8 zeros, neutrals. Neutrons, 1, 2, 3, 4, 5, 6, 7, 8. So I'll make this smaller font. So still analyzing the nucleus. All right, so this is a nucleus. We have 6 protons, 6 positives, and 8 zeros. Question for you. What is the overall charge? So this guy right here, what is the overall charge of just that nucleus? If I have 6 positives,
Negative.
positive, negative, where's the negative from? There's no negatives in there to make it negative. So the overall charge, no big deal. So the overall charge here, we're analyzing it. I have protons, which is equal to 6. That would be like plus 1, plus 1, plus 1, plus 1, plus 1, 1, 2, 3, 4, 5, 6. If I add all those pluses together, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1, this equals positive 6. But don't forget the neutrons. You could forget the neutrons, not a big deal. If I take 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, and I add all those together, 0 plus 0 plus 0 plus 0 plus 0, I don't care how many times you add it, it's still going to be 0. My question was, what's the overall charge of the nucleus? Plus 6 plus 0, the overall charge of that nucleus is plus 6. So now you can figure out, now you know it's not going to be negative anymore. There's no negative charges in there. It's going to be positive 6. So the overall charge of this entire nucleus is the nuclear charge. That nucleus has a charge of plus 6. The protons tell you the nuclear charge. All right, so now let's do the second part of this atom, which would be the electrons. I'm going to the reference table. We'll look at carbon again for a second. And the electron configurations up here says electron configurations 2-4. We know there's 6 electrons, but 2-4 is going to tell you the electron configuration. So if I do 2-4, if I write 2-4, it's going to tell you some information about the atom. So electrons, I'm going to put below that is just 2-4. This is going to have 2 rings. So you have the nucleus, and then I make a ring here, so like a Bohr ring. I'm going to take a circle. I'm going to go to shape, add another circle. So add a circle here. Try that again. If you go to shift again and make your circle, it's going to be a nice even circle. I don't like it painted in, so I'm going to change the color to transparent. And I'm going to move this around so it's like even. The cool thing about these like Google Docs is when you have these lines in there, you can figure out where it's going to be even on the x-axis, horizontal, and the y-axis. Once you have that bullseye, like the x and the y quadrant, there it is. You're pretty much centered. All right, so this is the first ring. I'm introducing this now. I don't expect you guys to memorize all this stuff right now. I do eventually. So the first ring has 2 electrons. Yes, Joseph, perfect. First ring's gonna have 2 electrons, and there's a second ring which is gonna have 4 electrons. So I'm gonna represent my electrons with small little circles, shape, shape. And from this point on forward, my electrons are gonna be smiley faces. So I'm gonna take a small little smiley face, I'm gonna color it yellow. Just so we know, my electrons are gonna be smiley faces. We're excited. So every time I have a little smiley face, it's an electron. So how many electrons do I need? I need 6. I'm gonna take that 1 electron that I created. Anybody need help making a smiley face? Add some joy to your day. Sun's coming out, Proctor at least. All right, so go to shape. Find that smiley face. And make a small little circle. I don't care what color you want your smiley face to be. Mine's going to be yellow. I'm happy. So you made a smiley face. Click on that smiley face. There should be a blue box around it. I'm going to copy it, hit Control C, and then I'm going to paste it in there. How many times? We have 6 electrons. I need 6 total, so I'm going to paste it 5 times. 1, Control V, 2, Control V, 3, 4, 5. You should have 6 smiley faces or 6 electrons in there too. So electrons are smiley faces. I'll label this too. I'm taking 2 electrons. I'm putting them on my first ring. Because this number right here tells you how many electrons in the first ring. There's 1, there's 2. There's 2 electrons in the first ring. And the second ring is going to have 4. So this is going to have 2 rings. Make another ring. I'm going to shape, shapes, circle or oval. This one's going to be bigger. You have shift, make your bigger circle, release. And then I'm going to take that color away. Transparent means it's going to be see-through. I'm just going to, it was fine the way it was if you want it to be, but I'm going to make it so it's even. So now I have 2 on the first ring, and now I'm going to have 4 on the last ring. So I have 4 more electrons. I'm going to put 1 here, 1. Doesn't really make a difference where you put them. 2, as long as you have 4 in the second ring. 3, and then 4. So this actually would be an atom for carbon. This is what carbon looks like now. So this carbon up here looks like this. We know the nucleus has protons and neutrons. We know there's 6 positives. There's 8 neutrals and neutrons. The overall charge of the nucleus is going to be 6. We know there's 6 electrons. These little smiley faces. I'll make one more. So my electrons are smiley faces. And there's going to be 6 total. 2 on the first shell, 6 on the second shell. You can never have more than 2 electrons in the first shell, but we'll get into that more and more. Let's label this. Does anybody need more time making this atom? Frank, you need more time or are you good? Okay, no problem. Frank, just chat me when you're ready. I'll wait on you. So I just asked Frank because he's the last name up there. So, well, we're getting to chemistry. It's an atom. Cool stuff here. If you can make an atom for a carbon, you can make an atom for anything now. All good. All right, so I'm gonna label this blue thing here. I'm gonna call it my nucleus. So I'm gonna put another text box. Why? Because I want to write on this a little bit. So I'm gonna.
Mr. Brown, I think I emailed you about it. I have a doctor's appointment at 1.
Okay, I didn't check my emails lately. I was in class all day, so. All right, that's fine. If you have to go, you have to go. Nothing I can do about that. All right. So anyways, nucleus. I'm gonna label it. So I did a text box. So text box T, and I made a text box. I'm calling it a nucleus. So in that text box, I just put nucleus. We're gonna label it. You too. So there's nucleus. We're gonna put a little arrow to it. So arrow is under my segments. I'm gonna say, hey, nucleus is right here. My nucleus, boom, there it is. Nucleus is protons and neutrons. I mean, these little things right here are electrons. So instead of putting another text box, I would just copy one of these little smiley faces, Control C, then hit Control V. They just paste it up here and say, oh, there's my little key. Oof. Messed it up a little bit. Pull that electron and we'll just put it up here and say, oh, that's an electron. Two of them on top of each other. Foolish electrons. So that's an atom for carbon. We'll practice more of them. All right, so my question earlier was, what's the overall charge of a nucleus? Some of you guys said positive. It was +6 after I did the math on it. My question for you now is, if you have this entire atom, this whole atom right here, what's the overall charge of the atom? I'm saying protons, neutrons, electrons, this whole thing. What's the overall charge of this atom?
Would it be 0?
Who's this? Who's this? Alex? There you go. It's 0.
Yeah.
It's 0, Alex. Nice. So it is 0 overall charge of the atom. So how did Alex get this? We have 6 protons, 1, which are positive, 2, 3, 4, 5, 6. We have neutrons, which are neutral. So maybe let's actually write this one in here. Let's just put this one in here as text box instead of me just doing it. So go to the text box, make a nice long horizontal text box. We're going to go through each one of these. We have protons, which are positive. Again, I don't care if you put that positive up there. It should be, but it's not a big deal. Protons, you can see to the left, there's 6. So protons equals 6 positives. 1 positive, 2, 3, 4, 5, 6. Neutrons. Jimmy Neutron again. Says it to the left in the, obviously the nucleus, there's 8 neutral charges. And electrons, you should know that electrons are going to be negative. Electrons are negative. You're going to have to know that one. There are going to be 6 negative charges. Negative 1. 1, 2, 3, 4, 5. I'm trying to line them up, but my dashes aren't really lining up too well. All right, so that was my question. What's the overall charge of the atom? This will help you out quite a bit. If you cancel out your protons and your electrons, so +1 and -1 cancels. Let's cancel some stuff. So this right here would cancel. Gone. +1 cancels with a -1. Gone. +1 cancels with a -1. Gone. This cancels. This cancels. This cancels. What's left? A couple zeros. What's the overall charge of an entire atom? So this entire atom equals a charge of 0. The protons cancel out with the electrons. There's 6 positives. There's 6 positives. There's 6 negatives. Those cancel on out. Overall charge of the atom is 0. On the other hand, like we talked about earlier, the overall charge of the nucleus is a different type of question. The nuclear charge is going to be equal to the number of protons. All right, if you understood 3/4, half this stuff today, you're in good shape. I'm definitely going to go through this stuff more throughout the duration of the unit at least. Once you're done with this diagram, you can save it and close it. We're also that drawing there. Save it, close it. Playing a video on the atom.
Atomic structure. In this video, we're going to go over atomic structure in a very simplistic and basic way. Atoms are the basic unit of chemical elements. They contain subatomic particles in their nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include protons and neutrons, which are located in the nucleus, and electrons, which are located in the cloud or field that surrounds the nucleus. Protons have a positive electrical charge, neutrons are uncharged, and electrons have a negative charge. The number of protons and electrons are equal, so atoms are electrically neutral particles. If we look at a model of the element carbon, which has 6 protons, 6 electrons, and in most cases 6 neutrons, we can see the electrons in simple rings or shells surrounding the nucleus. Each shell represents a different energy level, and it can only hold a certain maximum number of electrons. In chemical reactions between atoms, only the electrons in the outermost shell participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are required for stability. If we look at helium, which has only one shell or energy level, we see that it is full because it contains 2 electrons. So helium is stable, and there is no naturally occurring compound containing helium. Hydrogen, which also has only one ring or shell, possesses only 1 electron in its shell, so it's chemically reactive. In atoms with more than one energy level or shell, 8 electrons are required in its outermost shell for stability. So neon, which has 8 electrons in its outermost shell, is stable, and oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do have fewer than 8 electrons in their outermost shells will try to share, gain, or lose electrons in order to become stable. This is called the octet rule, but there are some exceptions, such as we saw with hydrogen and helium, which have only one energy level or shell. And that be the basics on atomic structure.
There's the atom. So we will get more and more detail about that as the time progresses. So if yours looks funny like this when you saved it and closed it, there's these little margins on top. Just pull that margin on over the tab. It should be able to organize itself. So I'm gonna leave this actually diagram pretty big. So I can analyze it, think about more examples, just like that. So then I could go back and review this of how to make an atom. Are we making more atoms? Absolutely. Like there's a whole topic in electric configuration where we're making a ton more, a little bit further. So we'll make more atoms as we progress throughout the duration, but there's one of them. All right, moving on forward. Let's go through these example questions now. I'm gonna wait till a few of you guys give me the right answer, and then we'll move on forward from that. So here we go. Practice questions from this topic. I'm gonna do the first one for you. What is one thing about you that always can be used to identify you because it never changes? So you guys all have your name. You all have a social security number, which you might not know yet, but you definitely know that as you get through college applications or filling out your FAFSA, your financial aid forms, or later on in life, you're gonna need them. So social security number, your name, maybe your fingerprints. That's your identity. All right, so that's easy, starting off pretty basic. Number 2, which of the numbers above is the one thing that can always be used to identify an element because it never changes? Which one of the values above are used to identify an element? Please privately message me. Once I get 5 correct answers, I'll go up there and put the answer up here on the board or screen. Which one thing's used to identify an element because it never changes? Yes, Joey, thank you. Yes, Tintin. Yes, Faith, that's 3. Yes, Kim. Yes, they know. Atomic number, perfect, thank you. All atomic numbers. Atomic number is how we identify an element, or you could have put proton number. Atomic number or proton number. The total number of electrons in a neutral atom is the same as which number? Electrons in a neutral atom are the same as which number? Please privately message me or chat me. Yes, Joseph. Yes, Tintin. Yes, Joey. Yes, Tristan. Tristan, thank you. Stand out. Protons. Protons are equal to the atomic number, or they're also equal to the number of electrons in a neutral atom. So you really want to make sure you understand this concept because next class it's going to get a little funky. Protons or atomic number. Number 4, which of the subatomic particles are located in the nucleus? I think we know this one by now. Protons and neutrons. Protons, neutrons, and that solid dense core. Know that one. Electrons orbit. They're so small they orbit around it. Which of the subatomic particles are located outside the nucleus? Electrons. I just gave it to you. Stop talking and just read the questions. Number 6, which of the subatomic particles have a charge of plus, and which one has a charge of negative? Yes, Leonardo flipped, correct. So positive is going to be protons, good. And negative is going to be electrons. Yes, Joey, thank you. Negatives are going to be electrons. Proton positive, electron negative. Number 7, which subatomic particles have a mass, let's say, of 1 AMU? Because they really technically all have mass, but which ones have a mass of 1 AMU? Yes, Joe. Joseph. One more, Philip. Yes, Alan. Yes, Nando. And one more, Emma. Yep, that one's right. One more. Protons and neutrons. Oh, we're growing in one class. Protons, neutrons. All this stuff we're so confused about being in class. Hopefully you're starting to make that connection. We'll just keep hammering it throughout the year, so you'll get there. What is the term for particles in the nucleus? Subatomic particles located in the nucleus are called what? No one in period 3 or 4 got this one. Oh, starts with that. Sounds like that, Santino. There's 2 letters. Those are in there, but what's the term for subatomic particles that are in there? Yes, Jumila. There it is. Jumila came through. Nucleons. Nucleons. That is going to be, gosh. Gone. It's okay, Joseph. It's okay. Don't worry about it. Nucleons. There it is. Nucleons. Well, protons and neutrons. Any subatomic particle found in the nucleus. I was cussing over here too, Joseph. All right, number 9. If you know the element symbol, for example, F, which of the numbers from the previous chart do you automatically know? So you know the symbol. What else could you automatically know? I'm just going to write a bunch of them down. Atomic number. Yes. Protons. Yeah, electrons can be a little funky. Yeah, you could go with configuration. Don't put electrons for now. Mass is going to differ at times. That's with nuclear charge. So there's several things you could automatically know. These are like all teals I had in that chart before. They're all the same. If you know the nuclear charge of a nuclear charge or the number of protons in a neutral atom, what other numbers or information do you also know? So we know the nuclear charge. We know number of protons. We also know electrons. And atomic number. Good. Number 11, last question from this page. I won't go through some exit pass questions or maybe review. In a neutral atom, the number of which two subatomic particles is always the same? The number of which two subatomic particles are always the same? Let's go chart. Subatomic particles charges are always the same. I like that question. So the charges are always the same. Yeah, protons and electrons. If it said mass, it'd be protons and neutrons. Protons and electrons. The protons and electrons have to cancel out. Okay, so that is topic 2, subatomic particles. Definitely something you definitely want to make sure you know how to do inside and out. So as you do the exit pass, you definitely want this too. All right, moving forward. So back to your home screen page for your Google Classroom page. I do want to analyze one more, just one more to go through. Atomic concepts for element B. So I'll click on this one. We'll do this one together too, and whatever time we have remaining, we'll just do exit pass questions.
Wait, was number 11 again?
Protons and electrons.
Thank you.
Charges cancel out. Hey guys, that's it. All right, so you go for it. Just kidding, I know I was muted. So please open up the template here and it's on Google Slides, and we'll do this. Once I get 5 of the right answers, I'll move on forward, and maybe we'll have some time for review for the exit pass if you want. All right, so the first thing up is determine the following for B. We have name of element, atomic number, proton number, neutron, electron, configuration, mass number, nuclear charge, atomic charge, and then you're going to draw it as well. So let's go through this. So we want to figure out the name of B. Check out the reference table, find B, maybe page 9 and 10. You can find B, but on the periodic table, it's not going to tell you the name of it here. What's the name of B? Check the next page. Please put your answer. Thanks, Alex. It's going to be on the next page, name of this element. Thanks, Kai. Good. Thank you. That element is right here, boron. Element is boron. So boron is the element. What's the atomic number for boron? Thanks, Michael. Boron. Thanks, Faith. Good, good, good. It's definitely going to be 5. It says right there. So atomic number is 5. How many protons do I have for boron? Thanks, Asim. Atomic number equals proton number. 5 for atomic number. There's 5 for proton number. So now I'm going to go up to the elemental box for boron. Zoom in on that one. That's all the information I get from there. There's boron. All right, skip number of neutrons for now. How many electrons do we have for boron? Good. Add 2 plus 3 gives you 5. What's the electron configuration for boron? Thanks, Alan. 2-3. The mass number in this situation is going to come from this top number. So mass number, atomic mass is coming from here, but it's got to be the whole number. So if the number to the 10th place is greater than 5, then this would round on up. If it's less than 5, if it's 4, 3, 2, 1, 0, you leave that number alone. So since it's got to be to the whole number, this is greater than 5, it's got to be 11. So the mass is going to be 11. The units for mass is going to be AMU. Next class, we're going to go through atomic mass. We'll get to that stuff too. AMU. What's the nuclear charge? Charge of the nucleus. Two right answer so far. 3, 5. Proton number equals the nuclear charge. Let's do the number of neutrons. How many neutrons? Neutrons are calculated by taking the mass, 11, subtracted by the atomic number, proton number, 6. Thank you. A lot of sixes there. Atomic charge. Oof. The overall charge of the atom is equal to, so if you count protons, your neutrons, and your electrons, what's left? Thanks, Alex. Thanks, Joe. You took the wrong one. Don't worry about neutrons. Neutrons aren't negative. You meant neutral, right, Kai? So if you take your protons, which are 5 positives, you take 6 zeros, don't even worry about them, and you take 5 negatives. So 5 positives plus 5 negatives equals 0. So the overall charge is going to be 0. Now let's see if I can hammer this out quick. We'll make an atom here. Same thing we did for carbon. So go to insert, insert shape, shapes, 0. We'll make this quick. So I don't want to run out of time. So I'm going to just hammer through this quick. I'm going to go through it. So protons equals 5. Neutrons equals 6. Five positives. And below I'm putting 6 zeros. Almost. I'm going to add 2 shells. So I don't care if you do this or if you just want to watch the rest of this for class. There's 2 shells, and I need some electrons that correspond with it as well. When you do your exit pass, I would definitely use your notes and definitely use your reference table for the exit pass. I will hang out for a few minutes and do a few questions over class. If you have free time, you're more than welcome to hang out with me and do them too. But you definitely want to use it. That's an electron. I need to have 5 electrons. So I'm going to copy and paste this 4 more times. The first shell has 2 electrons. Oh, I thought his tongue was out. It looks like his tongue's out there, doesn't it? So 2 on the first shell, and then the second shell has 3. 1, 2, 3. This one's for you guys. Good job today. All right, so that is going to be an example. We'll start class from now for like the next week by doing more of these. So we'll do more elements. You'll be able to understand all this stuff inside and out through duration. So that is really it for class. I'm going to do some exit pass questions. You're welcome to leave if you want to, but I'm going to do maybe 3 or 4 exit pass questions to wrap up class. If you want to leave, have a good day, have a good weekend, stay safe, be smart, wash your hands, wear a mask when you go out in public. Have a good Halloween, guys. We'll see you later. If you're going to hang out,
Have a good weekend.
You too. You don't have to submit this, just a little heads up. If you want to hang out and do a couple questions, you're more than welcome to. I'm going to do them. Hopefully, maybe I'll do them by myself, but I'm going to do a few of them right now. All right, so you definitely need a periodic table or reference table for doing these, or your notes. In a sample, in all samples, the elements of potassium each have what? So what's going to be the same for each atom of potassium? I'm going to find potassium, which is K. It's right there. This thing that's always going to be the same is going to be the atomic number, or the number of protons. So the thing that's always the same is the proton number for that one. Neutrons could change. It's not always going to be 20 neutrons. Second one, an atom of argon 40 has a nucleus that contains a total number of what? So find argon. Actually, you don't even need to find argon because we have the mass over the proton number, and then you have this. You have the symbol. Thanks, Nidal. Nucleus, though. In the nucleus, Nidal. So nucleus got to do protons or neutrons. Electrons aren't in the nucleus. That number at the bottom is going to tell you the proton number as well. So proton is going to be the best answer for number 2. So that would be B. Number 3, which subatomic particles have a mass approximately 1 AMU each? 1 atomic mass unit each. Which ones have 1 AMU? No, check out the notes again. Mike, check out the notes. Protons and neutrons both have a mass of 1 AMU. Protons, neutrons, mass of 1 AMU. You can see that right here. 1 AMU, 1 AMU. Protons, neutrons. Number 4, which is the charge or mass of proton? Charge and mass of proton. I was just there. Proton's mass, boom, charge, positive. Charge, positive. Mass, 1 AMU. So find proton. It's got to be +1 and 1 AMU. One more question. K42 contains the nucleus of K42. So there's nothing with electrons. I can't get any there. K42. Bye, Joey. Have a good one. Find K. There's K. K42. That number right there is my atomic number. So 19 is my atomic number or proton number. So atomic number, proton number, same thing. It's B or it's A or B. Now neutrons come from the mass, which is 42. Don't take that one. It's a little bit different here. 42 minus the proton number. 42 minus 19. Yeah. Thank you, Nadal. Choice A is the best one. Do another one. Why not? Choice A. If you guys have questions, let me know. I like the small group here. Number 6, which statement is true about the charges assigned to electrons and protons? Electrons, protons. Use your notes again. Electrons, protons. Electrons are negative. Protons positive. Answer. Nadal said C. Electrons negative. Protons positive. Good. C. Electrons negative, protons positive. If you have class in Bell area range, just so you know for a dismissing class. Number 7, which of the phrases best describes an atom? Yes, Michael. Nucleus is positive, surrounded by a negative charge cloud, electron cloud. B's the right answer. So think about your atom. Your atom, your nucleus. In the nucleus are protons and neutrons. The overall charge of the nucleus is positive. Rutherford said it was a solid, dense, positively core surrounded by electrons, which were negative. So that is an atom. Let's do one more to wrap it up. What's the total charge of a nucleus of nitrogen atom? Just the nucleus. Nucleus, you have protons and neutrons. P plus, and you have your neutrons. Nitrogen is N. So find N, which is right there. We have 7 protons. So equals 7. So P plus is 7. And I really don't even care about my neutrons because wherever it is, there's a bunch of zeros just hanging out. It's your overall charge here. Overall charge is choice 7. C is the overall charge. So 7 is it. All right, guys, have a good day. We'll see you later. Make good decisions. Take care.
Bye.
Bye-bye. Have a good one. See you later. Have a great day. Hello, how are you?